Today's honors geometry lesson is on section 7.7, the lengths of segments in circles. The objective is to solve problems involving lengths of chords, secant segments, and tangent segments. Theorem 7-11 states, when two chords intersect inside a circle, the product of the lengths of the segments of one chord equals the product of the lengths of the segments of the other chord. So let's go ahead and look at a few examples using this theorem. So for each figure, we're going to find x. So in figure 1, if we take 5 times x and set that equal to 6 times 3, we will be able to find this little segment here. So 5x equals 18. So x is going to equal 18 fifths, or x equals 3.6. So if you want to check if you're correct, you can go ahead and substitute back in 3.6 for x. So if you check, 5 times 3.6 does equal 6 times 3. For the second example, we know that this segment here is x. We know that the entire segment of AB is 19, so then this segment here is going to be 19 minus x. So now if we go ahead and set up our equation, we're going to have x times 19 minus x is equal to 15 times 6. So if we distribute, we're going to have 19x minus x squared is going to equal 90. So we're going to go ahead and set this up so we can factor. We want to keep that x squared term positive, so we're going to move everything over to this side. So we're going to have x squared minus 19x plus 90 is now equal to 0. So we're looking for two numbers that multiply to 90 and add to negative 19. So our two factors are going to be x minus 9 and x minus 10. So if we actually take the x minus 9 and the x minus 10, and we set that equal to 0, we know that the solutions are going to be x equals 9 or x equals 10. The next theorem, 7-12, states, when two secant segments are drawn to a circle from an external point, the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. To help you understand what this theorem states, I have a picture here for you. So what the theorem states is that if we take the external segment A and multiply it by the entire secant segment of B, we can set that equal to the external segment C times the entire secant segment, which is D. So to help you learn that theorem, we can say A times B is equal to C times D. So let's take a look at an example using theorem 7-12. So for each figure, we're going to find x. So remember, we're going to take the external segment times the entire secant. So we can take, in this case, we can take 6 times the entire secant segment, which is going to be x plus 6, and set that equal to the other external segment, which is 5, times the entire segment. Now remember, you want to take the entire segment, which is going to be 15. And then we can go ahead and solve. So if we distribute, we're going to have 6x plus 36. It's going to equal 75. And then if we subtract 36 from both sides, we're going to have 6x is equal to 39. And when you divide both sides, we're going to get x equals 39 6, or if we divide that, we can say x is going to equal 6.5. So looking at the second example, we're going to go ahead and use the same theorem. So if we look here, we know the entire segment down here is 18, and we know that if this segment here, which is the chord, is x, this must be 18 minus x. So now if we set up our equation, we can take 18 minus x, which is the external segment, times the entire secant, which is 18. Set that equal to the other external segment. So if this is 15 and the whole thing is 20, this external segment is 5. That's going to be equal to 5 times the entire secant segment, which is 20. And then we can go from here. So 18 times 18 is 324 minus 18x. And we can set that equal to 100. So if we subtract 324 from both sides, we have negative 18x. It's going to be equal to negative 224. And when we divide by negative 18, and we simplify that, so we're going to get a positive 224 over 18, which we can then reduce to 112 over 9. And if you want to get an approximation, if we actually take 112 and divide by 9, x is going to be approximately 12.4. The last theorem we're going to look at is Theorem 7-13. When a secant segment and a tangent segment are drawn to a circle from an external point, the product of the lengths of the secant and its external segment is equal to the square of the length of the tangent segment. So again, I have a diagram here, and I went ahead and gave you a little formula to help explain Theorem 7-13. So we can take the length of the secant times its external segment. So we can take A times B and set that equal to the square of the length of the tangent. So in this case, C squared. So A times B is going to equal C squared. So again, let's take a look at two examples relating to this theorem. So for each figure, we're going to find the indicated variable. So for this first example, if we know that from here to here, so if this chord is x, then this external part of the secant must be 10 minus x. So now we can go ahead and start setting up our equation. So we can take the external segment, which is 10 minus x, times the entire secant segment, which is 10, and set that equal to the tangent squared. So set that equal to 4 squared. So if we distribute, we have 100 minus 10x is equal to 16. If we subtract 100 from both sides, we're going to have negative 10x. It's going to be equal to negative 84. And if we divide both sides by negative 10, we're going to get positive 84 tenths, which we can reduce to 42 fifths. And if you want to get a decimal, we can go ahead and divide that, and that gives us a nice decimal of 8.4. So the last example is going to ask us to find x, y, and z, so we're going to use all three theorems for this one. So let's go ahead and start with x. Okay. So if we look at x, x is going to be part of a secant segment. So what we can do is we can go ahead and use this tangent here and use the last theorem we talked about that says if we take the external part of the secant times the entire length and set that equal to the tangent squared, then we can find our missing segment. So for number 1, we can go ahead and take the external segment, which is 4, times 4 plus x. I should say the quantity of 4 plus x, set that equal to the tangent squared. So we have 16 plus 4x is going to equal 36. When you subtract 16 from both sides, we're going to have 4x is going to be equal to 20. And now we know that x is going to equal 5. So let's go ahead and try to find y. So if we look at y, y again is part of the secant segment. So now that we know this entire secant segment, we can go ahead and use the second theorem that we talked about today. So we can now take the external part of one secant, which is 4, times the entire secant, which is 9. We can set that equal to this external segment times the entire secant segment, which is going to be 5 plus y. Okay, so 4 times 9 is 36. It's going to be equal to 25 plus 5y. If we subtract 25 from both sides, we have 11 is now equal to 5y. And when you divide both sides by 5, a y is going to equal 11/5. Or if you want a decimal, we can go ahead and say that that is going to equal 2.2. Okay, so now we can go ahead and fill in 2.2 for y. And then the last thing we can do is we can now find z. So our third step is we can find z. Okay, so z is going to be the entire segment. So if we take 5 plus 2.2, we now know that z is going to equal 7.2. So this is the end of our video lesson. If you have any questions, make sure that you go ahead and write those down. Bring them into the next class. And if you still have questions, feel free to watch the video for a second time. And if you watch that video for a second time and you still find that you have questions, make sure you see me at the next class.